All right, this is the Chapter 2B quiz. Which of these plots is impossible? The one that's impossible is B, and the reason it's impossible is because at particular points here and here, for example, or here and here, for example, you are in two positions at one instant in time, and that is impossible. Park is running slowly in gym class, but then he notices Jenna watching him, so he speeds up to try to impress her. Which of these graphs could represent his motion? So he's running slowly in gym class. That means that you're going to have a small slope, and then he speeds up, and then you're going to have a bigger slope. A small slope, and then a bigger slope. So that would look like here, for example, and then he speeds up, and you'll have a bigger slope. Notice that that's going to be in the positive direction. An alternate answer, and I would give the correct answer for this as well, is here, where I have a small slope, and then I have a bigger slope. Now those are in the negative direction, but the magnitude of his velocity has still increased, although in the negative direction. So either C or D, I'd give credit for either of those. The graph of position versus time for cars given below. What can you say about the velocity of the car with time? So right here I have a very big velocity, and then the slope gets smaller and smaller, so it's going to be slowing down. Let's see, so A is not an answer, so it must be B. It's not C because it doesn't move at a constant velocity, and it's not D either. It might be E, but that's not the right answer. So B is the correct answer. Consider the line labeled A in the V versus T plot. How does the speed change with time for line A? Look, this is a velocity versus time graph, so not really looking at slope, you're just looking at how it changes with time. The velocity increases with time, so that is B. All right, consider the line labeled B. How does the speed change with time? We're looking at the speed, and this is velocity that's plotted. So remember, the direction is given by the sign. So here I have a big positive velocity. It decreases until it goes to 0. And then it increases in the negative direction. So first it's going to decrease the speed, that is. It will slow down until it comes to a stop, and then it's going to increase in the negative direction. So decrease and then increase. This scenario, by the way, is like when you throw a ball up in the air. It goes up, it stops, and then it comes back down again in the negative direction, speeding up. All right, you toss a ball straight up in the air and catch it again right after it leaves your hand and before you catch it. Which of the above plots represents the V versus T? All right, just like I said before, this is 4 right here. I throw it up. It has an initial big velocity. It comes up, and then it comes back down. At the top, it has a 0 velocity. That's right there. And then it increases in the negative direction. That's right there. You drop a very bouncy rubber ball. It falls and then hits the floor and bounces right back up to you. Which of the following represents the V versus T graph? All right, so I have this ball. I throw it towards the ground. Here, it has a very large, or excuse me, it has a 0 velocity, and as it goes down, it goes in the negative direction. So here I have a negative velocity. That's going to get rid of this one and this one because those both have positive velocities initially. All right, so it's either 3 or 4. It has a negative velocity, and then it bounces. By the way, this is where it has its maximum velocity. It bounces, and it starts going back up again. Here, it's going to have a positive velocity. That's going to get rid of this one. All right, so let me show you here. 0 velocity, increasing in the negative direction until it reaches the floor right here. And then it bounces, and then it goes from having negative velocity to a large positive velocity. And as it comes back up, its velocity begins to decrease until it reaches your hand again. So 4 is the correct answer.